grateful for this day. We're grateful to be here working on some math. Help us that our minds will be open to understanding, that we'll be able to do well on this quiz, and that this weekend we can do well in our exam. That we may remember the things that we've been taught and that we've learned together. We love thee and we're grateful for this week, and continue to bless us. And we say this in the name of Jesus Christ. Amen.
Amen.
Okay, so let's just go ahead and get started on the quiz for today.
Swim from one side of a river to the other. Assume your speed is 3 miles per hour in the west direction. 3 miles per hour in the west direction.
Excuse me.
Let's see.
Excuse me.
So here we're just adding the two magnitudes, right?
I think so.
Oh my gosh. I studied this, but it's going right over my head right now.
Yeah. Yeah, it seems like you would add them since you'd be going, well, you'd be trying to go against, so you'd have to go in like a horizontal motion or a diagonal.
Yeah.
Is the thing.
So we
You'd be
need to
going
find that angle too.
yeah.
Okay. So Would we literally just say like 6.2 plus 3? Or
I assume so. I always hate having when they say like, make sure to write out all your steps and stuff. I never know how much to write.
better more than less, safe than
Exactly.
sorry. This, or do we have to reduce it down to the component form and then add that and find the new vector?
Um,
And find the new magnitude is what I meant.
right. I'm not sure which they want it or how they want it. It seems like you should just easily enough be able to just add them how they are right now.
Hmm. How about this? Let's I don't know, because I'm looking at the textbook right now, and the textbook is giving me equations for like vector sums, vector differences, and dot products and stuff. And for vector sum, it says a plus b, which is the magnitude, or vector a plus vector b equals the component forms a1 plus b1, a2 plus b2. So, yeah. Yeah, it says the sum can be found in component form by adding the components instead of drawing directed lines. Yeah.
Okay.
So, I mean, you could argue this, but I feel more comfortable putting it in component form and then adding it and finding the new magnitude.
Okay, we can do that.
So first I'm finding the component form of that 3 miles per hour in the direct west. Gosh, whatever that's called, direction. So why don't you find like the two other sides by going 3 cosine of 180 and then 3 sine of 180, since it's at a 180 degree.
Say that again.
So to find, let me think of what I'm trying to say. To find the other two sides or components of the vector 3 miles per hour, what if we define like the other two sides by going like 3 cosine of 180 degrees and then 3 sine of 180 degrees?
I think so, yeah.
And then for the other one, it would be 6.2 cosine of 90 degrees. And then 6.2 sine of 90 degrees. I hope I'm doing this right because really I'm like 50% here. I'm not sure. I got the component form coordinates of, for the 3 vector, it's -3, 0, and for the 6.2 vector, it's 0, 6.2.
Would you use the 180 for the 6.2 as well?
I wouldn't, because the vector is going in the direct north direction. And when you put the north, south, east, and west thing on a coordinate plane, going north is a 90-degree angle.
Oh, so you'd use 90.
Yeah.
Okay. I wasn't sure which one. Okay. Yeah, I got the same thing.
Okay. Cool. And then find the magnitude of that. So for the magnitude, I got approximately 6.89 or 6.9 miles per hour.
Mm-hmm.
Okay. Now, how do we find the new angle? Oh, look at this. In the textbook, it says the angle between 2 vectors.
Oh, perfect. Hey, Ben.
No.
We're working on the group quiz right now. We're still on number 1. We're working on the last part, the direction.
Oh. Um, um, so this might be wrong, but when you draw out this new vector on a coordinate plane, you go x equals -3, y equals 6.2, whatever. Those are the two sides of the triangle. And then the third side is that new magnitude, which is 6.89. So why don't you just use the law of sines? So the opposite angle of 6.89 is 90 degrees. And so like sine of 90 divided by 6.89 equals like sine of, I guess you'd have to do the arc sine or whatever, but then the opposite angle of 6.2.
Okay.
And then after finding that angle, because what we're really looking at is the angle from the other x-axis thing. It's more than a 90-degree angle is what I'm getting at. I don't know.
Yeah.
So sine of 90 equals 6.89. Sine of 90 equals sine of x is 6.2. So the equation to find that would be 6.2 times sine of 90 divided by 6.89, and then do the arc sine of that. So I got the smaller angle, or the opposite side of the angle of that vector is 64.179. And then wouldn't we just go like 180 minus that number equals the actual angle of that vector?
Yeah, I think you just have to minus it from 180 for the other side.
Cool. Whenever you're done with that, I got the angle for that new vector as 115.82 degrees.
115 point what?
0.82.
Oh, 82. Okay. 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 So this new angle we found, do we have to plug that back in, or for like law of sines? The 115.821.
I don't think so, because in number one it asks us what is your resultant speed and direction, and so our speed was the vector 6.9, and that direction is that angle that we just found, that one.
Oh.
Yeah.
Okay. Yeah. Are you ready to move on to number 2?
Yep, I'm ready. So in this one, because we don't have theta, we can't solve it. We're just kind of restructuring it, right?
Um,
I'm trying to find an example right now. I'm not sure.
Yeah. All the examples I'm finding, um, like in the textbook, they all have theta, or they're all being solved.
mhm.
I mean, this is what I did. This could be totally wrong. But we know that x equals r cosine theta and y equals r sine theta. And so I rewrote the equation to, like, I moved the 3 sine theta minus 7 cosine theta and multiplied that to r. So it's r times that equals 10. And then I distributed that, so it's r3 sine theta minus r7 flat sine cosine theta. So would that be like 3y minus 7x equals 10? Or it could be 3y minus 7x divided by 10 equals something? I don't know what it equals. I don't know.
Yeah, because in the book it talks about how r squared is equal to 2r cosine of an angle. And, or, no, r squared is equal to the x squared plus y squared. And then x is equal to r cosine of an angle. So in the book, one of the examples I found, it just says to times r, so you get r squared, and then put it to like to x and y.
Hmm. So did you come up with a new equation?
I'm not finished with it, but so far I have x squared plus y squared equals 10 over 3 sine of an angle minus 7x. Is what I have so far.
So I'm just going to throw out another equation. So I kind of, was following what you said, Rachel. And so because r squared equals x squared plus y squared, and we need to get r's in front of the sine and cosine thetas in order to make those x's and y's, I multiplied the entire equation, both sides, by r. So then I got r squared equals 10r divided by r3 sine theta minus r7 cosine theta. And then I switched that to x squared plus y squared, which equals r squared. So that equals 10, and then the square root of x squared plus y squared, because that's equal to r. So 10 times square root of x squared plus y squared divided by 3y minus 7x. So then they're all x's and y's, but everything is equal to r's.
Okay.
So you multiplied everything by r,
Yeah.
and then switched it out for x and y.
Yeah. Because I know that r squared equals x squared plus y squared, and regular r equals the square root of x squared plus y squared. Yeah. But yeah, I just did that because I knew that we needed another r in front of the sine and cosine thetas, but we needed to balance it on both sides.
Okay.
I have no idea if that's right, but I hope.
That's always the key.
Hmm.
Either do you want me to show you my paper to show what I did? I can, but
Let's see.
So do you always substitute x and y with r cosine theta and r sine theta? Is that just the rule?
yeah. Yeah, x equals r cosine theta and y equals r sine theta.
So what about when it has like an integer in front of it, like 3 or 7? Does that make a difference? Do they just remain? They just are there?
Yeah, I think it just stays there. Like instead of 3 r sine theta or r 3 sine theta, like 3y.
Right? Okay.
I'm not
so
sure, but that makes sense in my mind.
Yeah,
that,
that's what I can get.
that does. Yeah. So if we did that,
So I got r is equal to xy square root of 3y minus 7x over 10. Is that what you got, Sarah?
Well, say that again.
R is equal to xy, and then the square root of 3y minus 7x divided by 10.
I did not get that.
Okay.
I got just this big long equation with x's and y's. X squared plus y squared equals 10 times the square root of x squared plus y squared divided by 3y minus 7x.
Okay.
I got 3y equals 7x plus 10.
Fine. Oh my gosh.
I found one example in the book, and I don't know, it just looks like you just substitute the x and y and do a little bit of algebra to get the r equals. So if you're trying to get the other end of that equation to go back to y equals,
Mhm.
y equals x, it seems pretty straightforward. But I'm not sure if I'm even looking at the right stuff. So, because there are two different examples of the r squared equals x squared plus y squared,
Mhm.
and the x equals r cosine theta and y equals r sine theta. I don't know. I'm not confident on that at all.
Yeah.
What I looked at, number 3 in this quiz, it says to write an equivalent polar equation for the rectangular equation. So we're going to do the exact opposite. This says x squared plus y squared equals 9 times x divided by, whatever that is. Anyways. So I went ahead and tried to do that backwards. And so I knew that that first part was r squared equals 9 tangent of theta squared. Or you could say sine of theta divided by cosine theta squared, whatever.
Mhm.
And then I just square rooted both sides and it equaled 9, r equals 9 of tangent theta. And so I just kind of used that. So I did that backwards and then I redid number 2 and kind of applied those same principles. And that's how I got my answer. But it's
That makes sense. Yeah.
yeah. But Ben, what you said as well sounds right. Like I have no idea what I'm doing.
I'm not sure if those two things are if the rules, apply together or separately. I'm not sure.
Um,
Like I said, I'm not coming in this very informed either. So
oh gosh, me neither.
Yeah.
This week was hard for studying stuff, so
Yeah.
sure.
yeah.
Yeah, because if we r squared equals 9 y over x, what is that?
Y over x, that would be tangent of theta.
Oh,
Or you
oh, okay.
could say that it's also like r of sine theta equals r of cosine, or over r of cosine theta.
It's another way of saying tangent. Okay, I haven't ran into that yet. So I mean, is there even any calculating it? Is there any calculation going on in these, or is it just rewriting the formula?
I think it's just rewriting it.
Just rewriting it, yeah.
Yeah, I mean, because it says to write an equivalent equation. So
Yeah.
I literally just think that we're messing it around and coming up with a new equation.
Mhm.
Okay. Well then, number 2 seems okay. So on number 3, the left-hand side of the equation would be r squared, just automatically,
I think so, because that's what it says in the textbook. Is
right?
what,
X squared plus y squared is equal to r squared.
Yeah.
And then you have it equal to 9 tangent theta. So what do we need to do with the right-hand side of that equation? Just leave it?
with the right hand side. Oh gosh, I just lost where it was.
It'd be r squared equals
And just switch it
plus or
to
minus.
tangent.
It'd be plus or minus 9 tangent of theta.
I didn't think about doing the plus or minus. I don't know if you would do that.
Since it's r squared and you're trying to get it just to r.
Yeah. Yeah, I mean, yeah, because I did square root
You have
both
to square the
sides
right-hand
because that's a
side.
tangent squared.
Mhm.
And so you have to get rid of the square from both sides. So
Right.
yeah, in the end, I just thought it would be r equals 9 tangent theta. Or r equals 9 of sine of theta over cosine of theta.
Oh, since it has the square on the right-hand side, it would eliminate the plus or minus. Because when you get rid of the r squared, it would get rid of the squared. So okay, I think I follow you.
Maybe.
R squared equals.
Oh my gosh, I would feel so bad if we get our score back and all these questions were like 0, 0, 0.
I think she gives points for trying.
I hope so.
I hope so.
So in my head, number 2, I get 3y equals 7x plus 10. And then number 3, I get r equals 9 tangent theta. I don't know. That's where I'm gonna have to leave it. Everything else sounds reasonable as well. So I'm not sure.
Are we just like extremely overthinking number 2? Because like looking at number 3, do we just like put it like x squared plus y squared equals 10 divided by 3 y minus 7x and just leave it like that.
X squared plus,
Plus y squared
mhm.
equals 10 divided by 3y minus 7x. Because that's the same form that they have it in for number 3.
Well, that's what I'm thinking is they are two different polar equations, right? There's two different styles. But maybe I'm confusing myself with that. I don't know. See, there's the substitution of r cosine theta, or x equals r cosine theta, and y equals r sine of theta. That's one.
Yeah.
And then there's the other substitution of r squared equals x squared plus y squared.
Mm-hmm.
And according to the examples in the book, the number 2 is the first one of x equals r cosine theta and y equals r sine theta. And number 3 is the r squared equals x squared plus y squared. Because I don't think if you apply one or the other to the other, it doesn't make any sense. So for number 2, what did you get, Rachel?
I ended with r is equal to xy times the square root of 3y minus 7x over 10.
Times the square root of
3y minus 7x divided by 10.
Oh, wow. Okay. And then what did you get, Sarah, for number 2?
So I got x squared plus y squared equals 10 times the square root of x squared plus y squared over 3y minus 7x. And that's just from distributing an extra r to both sides of the equation so that we can get r squared on that one side.
Yeah.
So I just multiplied the whole equation by r and switched that to y's and x's.
And then what did you guys get for 3?
For 3, I got what you got, the r equals 9 tangent.
Theta?
That's what I got too.
Okay.
I wonder if we wrote down all 3 of our answers on number 2, if we could just write a little note that says, pick one, pick the right one.
Yeah.
I'm all for it. I'm not opposed to anything. So, because I mean, we could all chase it down the way we did our formulas, and it all makes sense, So I'm not sure
Yeah.
what to do. And then there's no real similarities. That's you guys got. I mean, yeah, I'm all good with that idea.
Oh.
Okay. Perfect. Well, let's go ahead and move on to number 4 then.
Okay.
Cool.
So this polar equation, is this just for graphing circles? I mean, is that what this is?
I think it's kind of like. I mean, I know how to graph a polar coordinate. I just don't know how to explain it.
Like what the application is? I'm just like,
It is. I mean, I guess you're using the unit circle to like know where to graph it, because 4 pi thirds is a third pi after pi.
right?
So you graph it there, and the line goes for 4 units. And so it's not like
4 units from
from the origin 0, 0.
Yeah, from the
Uh-huh.
center. Light goes
Oh.
out.
Yeah, it goes out for 4 units. It's not like X and Y coordinates. Like you don't go over 4 and down 4 or whatever, but it's just like diagonally 4.
right. Okay, yeah.
Yeah.
So that's the difference. Okay.
Yeah.
But like you explained, 4 pi over 3 is like a third pi over 4. So that's the translation. 4 units away from the origin, a third of 1 pi in rotation.
Yeah, so it's past 180 degrees by a third pi radian. Wow.
Because a half a pi is 180, and a third pi, or what, 2 pi, okay.
One pi equals 180 degrees.
1 pi, yeah, that's right, yeah.
Yeah.
Because 2 pi is 360, okay.
Yeah.
So 1 pi, and then a third of a pi. So you're still in the first and second quadrant on that one?
You'd be in the third.
Third.
Oh, really?
Yeah. I don't know if you can see my paper here, but
Yeah.
So
Yep.
that's 180, and then a third more down. So you're going in that direction. 4/3.
So third from 180. Why is that?
The radians that we're looking at is 4/3 pi, and so 1 pi is equal to 3/3.
Oh, it's okay.
1, 2, 3, and then one more.
Okay, so the 4 in the x position on the 2 coordinate on the plotting, that's our, okay. I was looking at it wrong. Okay, so
Yeah, the 4 is literally just like 4 units diagonally from that
Okay.
point.
so that's the translation, 4 units from the origin, and then 4 pi thirds is our angle.
Yeah,
Okay.
yeah.
Yeah.
Okay.
Yeah.
That makes sense. Okay. So what are some other coordinates that share that?
Well, if you're using degrees, it would be moving over or diagonally 4, and then it would be 210 degrees. Because you're at the
30
180, and then you move 30 degrees down. So 210.
Okay, that makes sense.
And another equivalent coordinate to make that 2. Another one would be 4, comma, -2 pi thirds, because if you go in the opposite direction,
Mhm.
then
Okay.
that would be 2/3 pi, or -2/3 pi.
Roger that. Okay.
Cool. Is that all we needed for number 4?
I think so.
Awesome.
I think we're solid.
Cool.
Yeah.
Okay.
Perfect.
Good?
I think we're good.
All right. Thanks, guys.
Thank you. See you Monday.
Yep.
See you Monday.
On the exam.
Yeah, good luck.
Good luck.